In this exemplary problem, we have two sources, sinusoidal sources, connected in series, and then they are connected to 10 ohm resistance. Our task is to find a current that flows through this resistance. Then this current, root mean square value of this current, it is a root mean square value of voltage across this resistance divided by the resistance. So the first step is calculation of this phasor of this voltage, of total voltage, which is sum of two voltages. To add them, we may add them graphically or algebraically, but first we have to convert cosinusoidal waveform that we have here. We have to convert this waveform into the sinusoidal one. Okay, we will apply a reduction formula. So if we have a cosinus of alpha, to obtain sinusoidal waveform we have to add 90 degrees. So we have 45 plus 90 degrees is 135, and that way we have obtained voltage source E sub 1 as a sinusoidal waveform. Now we may add these two phasors. We may add them graphically or algebraically. Let us start from graphical addition. This is voltage E sub 2, and this is voltage E sub 1. Please observe that 20, it is amplitude of E sub 1, then root mean square value, it is 20 divided by 2. 10, it is root mean square value. Okay, we may apply head to tail connection to find the total voltage. So we move this phasor to this position, head to tail connection to obtain a total voltage, which is 10 EJ 90 degrees. It means its root mean square value is 10 volt. Okay, the same now same addition, but algebraically. We have to add two phasors, two complex numbers which are expressed in exponential form. To add them algebraically, we have to first express each of these complex numbers in algebraic form using Euler's formula. So this is done here below. Now if we calculate the cosinus sinus of these phase angles, we obtain the following. Now we have to add real parts, imaginary parts to obtain the result, which is J10, and once again we have to turn back to exponential form to find phasor, which is 10 EJ 90 degrees, obviously exactly the same as we have had before, obtained by graphical addition of phasors. Finally, our current is 1 amp. 10 volt divided by 10 ohm is 1 amp. Okay, and this completes calculations.